Good morning, my name is Daniel Muret and I am going to be talking about a type of metal casting process which is called sand casting. First of all, what is sand casting? Sand casting is a metal casting process characterized by using sand as the mold material. As its name literally says so, sand casting can also be referred to the object produced by the sand casting process. Sand castings are produced in specialized factories called foundries. Did you know that over 70% of all the metal castings are produced by sand casting? This makes sand casting the most widely used casting process in the entire world. Molds made of sand are relatively cheap and sufficiently refractory even for steel foundry use. In addition to the sand, a suitable bonding agent, which is usually clay, is mixed with the sand. The mixture is moistened typically with water but sometimes with other substances to develop the strength and plasticity of the clay, and this makes the aggregate suitable for molding. Sand casting utilizes expandable sand molds to form complex metal parts that can be made nearly of any alloy. Because the sand mold must be destroyed in order to remove the part called the casting sand, casting typically has a low production rate. The sand casting process involves the use of furnace, metal, pattern, and sand mold. The metal is melted in the furnace and then ladled and poured into the cavity of the sand mold, which is formed by the pattern. The sand mold separates along a parting line and the solidified casting can be removed. Sand casting is used to produce a wide variety of metals components with complex geometries. These parts can vary greatly in size and weight, ranging from a couple ounces to several tons. Some smaller sand cast parts include components as gears, pulleys, crankshafts, connecting rods, and propellers. Large applications include housings for large equipment and heavy machine bases. Sand casting is also common in producing automobile components such as engine blocks, engine manifolds, cylinder heads, and transmission cases. There are 6 steps for the process cycle in sand casting. First of all, mold making. The first step in the sand casting process is to create the mold for the casting. In an expandable mold process, the step must be performed for each casting. A sand mold is formed by packing sand into each other half of a mold. The sand is packed around the pattern, which is a replica of the external shape of the casting. When the pattern is removed, the cavity that will form the casting remains. Any internal features of the casting that cannot be formed by the pattern are formed by separate cores which are made of sand prior to the formation of the mold. The second step is called clamping. Once the mold has been made, it must be prepared for the molten metal to be poured. The surface of the mold cavity is first lubricated to facilitate the removal of the casting. Then, the cores are positioned to the mold halves are closed and securely clamped together. It is essential that the mold halves remain securely closed to prevent the loss of any material. The third step of the process cycle is called pouring. The molten metal is maintained at a set temperature in a furnace, and the mold has been clamped. The molten metal can be laid from the holding container in the furnace and poured into the mold. The pouring can be performed manually or an automatic machine. Enough molten metal must be poured to fill the entire cavity and all the channels in the mold. The filling time is very short in order to prevent early solidification of any one part of the metal. The fourth step of the process cycle for sand casting is called cooling. The molten metal that is poured into the mold will begin to cool and solidify once it enters the cavity. When the entire cavity is filled and the molten metal solidifies, the final shape of the casting is formed. The mold cannot be opened until the cooling time has elapsed. The desired cooling time can be estimated based upon the wall thickness of the casting and the temperature of the metal. Most of the possible defects that can occur are a result of the solidification process. If some of the molten metal cools too quickly, the part may exhibit shrinkage, cracks, or incomplete sections. Preventative measures can be taken in the designing both the part and the mold. The fifth step is called removal. After the predetermined solidification time has passed, the sand mold can simply be broken and the casting removed. This step, sometimes called shakeout, is typically performed by a vibrating machine that shakes the sand and casting out of the flask. Once removed, the casting will likely have some sand and oxide layers adhered to the surface. Shot blasting is sometimes used to remove any remaining sand, especially from internal surfaces, and reduce the surface roughness. Last but not least, the trimming step. During cooling, the material from the channels in the mold solidifies attached to the part. This excess material must be trimmed from the casting either manually via cutting or sawing or using a trimming press. The time required to trim the excess material can be estimated from the size of the casting envelope. A large casting will require longer trimming time. The scrap material that results from this trimming is either discarded or reused in the sand casting process. However, the scrap material may be needed to recondition to the proper chemical composition before it can be combined with non-recycled metal and reused. Thank you so much for your time. I hope you enjoyed this quick presentation.